Hi there, I'm Lucas and I'm gonna be your teacher in this course about SQL databases. In order to take this course, you don't need any previous knowledge since we're going to start totally from scratch, and we're going to learn everything from how to design a database to developing rather complex database consulting. If you want to take this course, be sure to leave a like, subscribe, and ring that bell so that you're notified every time I upload a video. If you want to help me out, you can share this video with someone who is as passionate for programming as you are. Are you ready? Let's go for it. Hey, how's it going? In this video, we'll talk about databases, and we're going to learn the main principles first. For starters, we have to understand what they are exactly. I don't like when people get tied up with concepts from the dictionary only to end up not understanding what it is. So well, what exactly is a database? In basic terms, it's a place where we can store data in orderly fashion. It's that simple. Now, for example, the most simple database I've seen in my life, I remember playing this video game in the year, when was it? 2005, I think? The video game was called Hellbreath. It was an online game. At the time, I wanted to upload online servers for this game. And something that drew my attention was that the whole database of the game were text files. As you see here, we have a notepad in which we can appreciate how one character's information was assigned. So basically, this is a notepad which stores all the data relevant to a character. The map it is located in, the character's name, the X and Y position in the map's geography. Well, this is a very video gamey thing, but the amount of health points it had, the level, everything. So this is what databases were back then. To put it simply, they were notepad files in which the information was stored. It was also organized in folders. In this case, each one of the characters had a different text file. And all of this was read by a program. And this was a database, as simple as it might seem. Now, what happens? Since then, databases have changed drastically with time. They're no longer what they used to be, no more are they notepads or loose files. Instead, specialized programs made to organize data started to emerge. This always happens with programming. It's like perhaps in the beginning, someone is in charge of practically everything, but after some time, different aspects are managed by different people. The same way a website went from being managed by a webmaster to having a front end and a back end. And then the front end was broken down to frameworks. Specialization became a thing. And that's exactly what happened to databases. So a notepad utilized to store data this way would be called a slot, which is a minimal entity of the database. And just as we have the notepad, an Excel sheet could also store data. And no, I'm not saying an Excel sheet is necessarily a database, but a considerable amount of people uses it as such. Now, when we put together a program or a system that attempts to manage all of this, it can truly be pretty difficult to get it to work at a functional speed. To load and read all of this data from notepads, Excel sheets, and those sort of formats requires a lot of programming, and it's rather slow. The processing isn't quite optimized. For this sole reason, systems 100% specialized started being developed and made available. But where is it we're storing all this data? Well, basically, we store it in computers. It's that simple. And now what happens? As these database managing systems appeared, they evolved the hardware continually in order to optimize servers as much as possible. This is where the first data centers came to be. What are these in basic terms? They're a set of computers that allow a database service to be provided. And the first data centers were designed following the classic architecture of network computing, in which the equipment units were stacked on tables and cabinets, making racks, right? The necessity of easy management and optimization of physical space led to taller and taller stacks of databases. Anyway, basically, that is where data is stored in these data centers. But now, a new technology known as blockchain enters the process. And what blockchain basically is comes down to a decentralized database. What does this mean? Let's imagine we have a number of computers in different locations of the world, and we have our database replicated in each one of these computers. This is unlike the way earlier data centers were, in which we had our database in a sole specific location. Having our database replicated in various different computers, instead of centralized in a single place, guarantees that if the information was to be modified in one of them, that doesn't affect the whole, and it provides a failsafe to authenticate or dismiss said change. But we might be getting ahead of ourselves here. We'll get to that. For now, let's just keep in mind the concepts alone. If we're going to talk about modern database systems, what types of databases are there? Well, they're mainly divided in two groups: relational and non-relational. A relational database is one that is based on the correlation between data. It doesn't account for chronological order of storage. In this relational model, the data is stored in a set of tables made up of rows and columns. If we focus on the example on screen, we'll be able to see the following. On one side, we have a product table. On the other one, we have a provider table. We also have tables for presentation, brand, and zone. Okay, each of these tables is correlated to each other. This way, what we achieve is to optimize the data and make it unnecessary to repeat the same information over and over all the time. So, for example, we have the provider table here. Now, the provider is only going to have two columns. Here we represent them this way, right? Because it's only the structure of the data. One of the columns would be the description, in which we'll type in the provider's name, right? And then we have the ID, which would be a number meant to identify this provider, a unique number. What happens next? In our product table, we'll store a list of all the products. We begin with the product's ID, meant to represent this unique specific product, put more simply, the identifier. Then we have the price, the product's description, how much of it is in stock, VAT, all of that information. But what of it? If and when we want to save the provider in this table, we have the provider ID. It's not like we're going to put in the name of the provider each and every time. Instead, we simply save a little number that will make a reference to this other table. And this is precisely why they get the name of relational databases, because they correlate to each other based on their ID. With this method, the information is fully optimized. Now, this is only the structure that our database will use. But later, if we desire to save information, consult information, or outright delete it, normally it's done with a language known as SQL, which we will know more about further ahead. This is just an initial glimpse to open the topic and getting into it. So, what types of relational databases are there? There's MySQL, which also exists in a version called MariaDB. It has a different name merely for bureaucratic reasons, but it doesn't matter. There's Oracle PL/SQL, SQLite, which is mainly meant for mobile devices, TransactSQL, which is the Microsoft version. There's also WebSQL, which is the web version, evidently enough. Finally, as you can see, all of these have the SQL acronym somewhere in their name. This is the language that allows us to consult information, as well as adding it, modifying it, and/or deleting it. On the other hand, we have non-relational databases, more commonly known as NoSQL. These databases are designed for models of specific data. They have flexible outlines for more recent, modern apps. They're easy to develop, they have great performance, and on top of that, they're scalable. Now, when we are using an app on our phones or any other system, it is fairly normal for it to send information to the server in a format known as JSON. This we see here on the right side is JSON. It's a way to organize information. A man named Johan Oscarsson came up with the following. Since all of our systems communicate using JSON, Why don't we make up a database that stores this JSON directly? And in the year 2009, in an open source event, he reintroduced all of these concepts. I say reintroduce because these are old concepts. They just were not used practically. Same thing happened with AI. All of these concepts existed since the 80s. It's just that several years had to pass so that computing power could become potent enough to really make these concepts a reality. So, these types of databases do not have a defined structure. It's very easy to add new fields, unlike SQL databases in which saving information can be a bit more complex. Here, saving information is much more simple. These were used for the most part by social media sites like Facebook to store big information lots in a simple manner, but also to be able to scale it. With scaling, I'm referring to the ability to have several types of databases distributed to many different servers and have them function in synchronicity. And I'm not talking about having the data synchronized, but having it work together properly. What non-relational databases are there? Well, the most famous of them all is MongoDB. Then there's also CouchDB. Unlike MongoDB, CouchDB is made to be better prepared for synchronicity. When we have, for example, an application that normally works offline, suddenly going online and having to synchronize an entire lot of information, well, this database is optimized to better protect the data from corruption. Next in line, we have Firebase, which, well, would not necessarily be a database more than it is a serverless that allows to store information in non-relational databases. We include it here so as to make a small summary. Now, what types of databases are there? Well, mainly we have the non-relational databases, MongoDB, the most famous of them all. There's also CouchDB, which is very much like MongoDB, with the difference of being particularly great for synchronicity. For example, when we have an application that works offline and it stores data, then it goes online, it has to synchronize this data. Well, CouchDB is very good because it controls all kinds of conflicts that might come up as a result. Other databases we haven't mentioned are Hadoop, Cassandra, Voldemort, the names they chose for these databases. But anyway, now we have a comparative chart between SQL versus NoSQL. The main advantages of relational databases are as follows. First off, maturity, meaning they've been in the market for too many years. On the other hand, we have atomicity. This means that if some sort of error were to come up in the process of making either a saving or deleting operation, this feature could revert the whole process without any sort of issue. Either it gets completed 100% or not at all. Their standards are also very well defined. They're all written under the SQL standard. There is a simplicity to its coding as well. That might be its main source of acceptance actually, since the coding is very similar to human language. The comprehension of the operations and the way it's written, we'll see that when we dig deeper into SQL. If we're talking disadvantages, the main one would be endless growth. These databases tend to overgrow, and when they do, the storage and maintenance are quite hard and rather expensive. Additionally, they tend to present issues with response time. Another con would be changes in their structure. If we had to modify the whole structure of the database, that'd be a complicated task. It might not present any issue, but if you're already running the database with a considerable amount of data and you have to make an important change, it could be truly complicated to refactor it optimally. Now, if we're talking NoSQL, the main advantages are that it's versatile. It's notoriously simple and easy to change the structure of the model that we might make up. We can add new fields without any kind of trouble. And it's precisely because of this that it got so famous and started being used so much. What am I talking about? If, for example, we have a document in which we're saving someone's personal information and we want to add a new field, such as a passport, we add it and that's it. It's saved, no problem. because it's getting saved as that isolated document. Another very important advantage is horizontal growth. They support decentralized scalability. That means they support distributed structures. If during the operation you can tell the performance of the servers dwindles a bit, new operational nodes get installed in order to balance the workload. And this is better known as horizontal growth. That is, instead of having one solitary server, adding more RAM, more hard drive disk, many servers get created horizontally, to put it simply. On the other hand, another advantage is optimization. No SQL systems have an internal algorithm to overwrite previous queries by users with the programmed applications. This is in order to avoid overloading the server's performance and to keep an optimal level in all operations. Now, if we were to talk briefly about disadvantages, the main disadvantage very well may be atomicity. What that precisely entails is that not all databases possess the feature of atomicity in their information. This means that, on occasion, the information is inconsistent. It may be different in each one of the replicated nodes. But well, this obviously varies from project to project. And what type of database is best to use for my project? Well, each project is a world apart. It will entirely depend on how it's organized and what it's meant to do. For example, if you're designing a project with more of a social network style in mind, in which you can save all kinds of information and every type of data, in addition to having an important scalability level on the server's end, your best bet might be something like MongoDB. In other words, a non-relational database. However, if your project is more of a managing system in which all the information is well structured and defined, perhaps the best fit would be along the lines of a MySQL database, isn't it right? A relational database. Well folks, I hope this information has been useful to you so far. If you liked it, let me know in the comments below, and I'll see you in the next one. Hello folks. In this video tutorial, we are learning how to design a relational database. The first question we have to ask ourselves is, at what point of the project do we have to design the actual database? Well, in most of the projects I've worked in, mainly, you start by defining the requirements the system in case will have, the whole scope, which means what's it gonna do, what functionality will it cover. Then, screens of how the system would look should be developed. For example, if we're designing a mobile application, we're going to design the login screen, then we'll preview how the dashboard will look, also the user management, and also we can see how it flows from screen to screen. Right after this, we'll be more or less prepared to put together a starting design for our database. The big idea is to identify all the components while designing the database and building the structure exactly the way it should be. Now, you better beware of the mistake I made many times, which is designing the database and executing the whole code. In other words, to create it with the entire structure defined. The ideal scenario is to first design a database, only the design, and then start generating parts of the database as the components are being programmed. So, the first step when designing a database would be to identify the component parts that our system will have. It could be the case that it has users, clients, stock management, and those sort of things. We'll write it down to have a closer idea of the entirety of the components the system will interact with. After that, we'll start subdividing it little by little in order to define the table structure that we might need. When designing the database, it's very important to try and predict as best as possible each and every component that we're going to need in our system. But it's very hard to be able to predict it all though. Don't go thinking that a first sketch will define your database in its entirety. Ideally, you can try to be as many steps ahead as possible, but well, if you don't cover it all, it's no big deal. We will see that a bit further as we progress in its development. Now, let's consider the next example. Say we're given the task to develop a database for educational academies. So, while studying for it, we identify that we have to save comprehensive data from teachers, students, courses, students' grades, and those sort of things. But in this case, say we have to build a database not for one singular academy, but our system will most likely include numerous other academies. We will also identify the component academy. Okay, now how do we design the tables to store all of this data? If we wanted, for example, to imagine how this would look in Excel, it could be something a little bit like this. On the one hand, we'd have a listing of school subjects put together. We'll enter the name of each one of them, mathematics, physics, history, and so on. And we will assign an identifier to each subject so as to tell it apart from the others, a number of identification. Then we could have a listing of students, right? Here we'll have name, surname. I'll leave it there regarding this example, but other variables could be address, phone number, document number, date of birth. In some cases, it's important that we don't focus on saving outcomes in the database rather than already set data, such as a date of birth. So instead of saving an individual's age, which will change with each passing year, it's preferable to save the date of birth, since we can always figure a person's age with that info, even if that's all we have. On the other hand, we have a listing of the grades each student will achieve. So we can see we have the subject mathematics, and Pedro Moyano scored a 7 out of 10. Or we have physics, and Eduardo Garcia scored an 8. And so on with each grade, right? Now, what happens? When it comes to designing relational databases, the idea is to attempt to optimize all the space at the time of creating rows for our tables. If you notice, we're repeating a lot of info here. We're putting in the subjects repeatedly, the names of the students too. Eduardo Garcia is featured many times. All of these are characters that weigh in our hard drive. And when we have millions of data and several tables, there's a moment in which all of this has a negative effect, not to mention how hard it might get to update the data. If I wanted to change a name, for example, to Pedro Moyano, say I originally made a mistake. The real name is not Pedro, it's Juan. I have to modify it in this table, and I have to do the same thing in this other table. And every table where this name is featured. Well, the key notion behind relational databases is to solve this very problem through ID management. So, a rather simple example, right, would be the following. In each list, every student would have an ID to identify it. For instance, Pedro Moyano is assigned the number 1, and each subject will also have an identifying ID, so that when grading becomes necessary, instead of using the name each time, we'll use this ID. And instead of saving the full name, we'll put in, say, student ID and the number to represent it with. This number 1 will be referencing this student here, Pedro Moyano. Now, the student with ID number 2 will reference the second one, Eduardo Garcia. Same with the subjects. The subject referenced with ID number 1 is mathematics. The subject referenced with ID number 2 is physics. We save the notes as we go on. Simultaneously, we can also have an ID to represent this transaction that was made with this grading process. It's always much easier to differentiate each row that we add in a table through an identifier. Each column has one type of data. As we can see, ID has a number, name and surname have text, and in every database system we can have the following types of data. Of course, these can vary a bit depending on the system. It varies a little between MySQL and Oracle, but generally speaking, most relational systems, databases, are managed through these types of data. To begin with, right there we see a type of data called char. This makes reference to a character. So this data type allows us to save a set of characters. We can set a size, and this one might range from 0 to 256. So we could save either words or very short lines of text. Such as a tweet, maybe. Yes, I think a tweet would fit this amount of characters. On the other hand, we have text, which allows us to save longer stretches of text. One is left to ponder, why? What's the need to alternate between char and text if text allows me to save all the char, covers, and much more? Well, let me tell you why. If you design a database where everything works with text, by setting each field on text, you're reserving a very large space for data that might not need it. For instance, if you need to account for gender, you can save either F for female and M for male. If you assign text type data for this, you're reserving a lot of room for something that's just not going to use it. What happens is that by gathering thousands of transactions, saving millions of rows, this is all going to rack up considerable weight, and the database will end up being too heavy. That's why it's so important to know what type of data is best for each case. Right after char, we also have varchar, which basically allows for a much larger set of characters. It ranges from 0 to 65,000. Then we have numeric type data, the first of which is tiny int, which avails for a very small amount. This number ranges from -128 to 127. This amount is determined by the size of 1 byte. It can range from 0 to 256, but so that this data type can range from the negative, it's split in half. And it's not 128 on the positive side because 0 is also a value. But anyway, this is very technical stuff, this last part. This number normally can be useful to account for Boolean values. You can save, for example, true or false type info by simply setting number 1 to stand for true and 0 for false. It could be, for instance, if you have a column called is an administrator and you type in 1, that means that person is an administrator. If you type in 0, that person isn't. Now, in order to save larger amounts, larger than 127, int is utilized. And it's quite extensive, as you can tell. Here I can't exactly make up how much. I believe it ranges from 2 billion, -2 billion, to +2 billion. But what happens? It's quite extensive, but maybe it's not enough, depending on the data you're using. If you're saving the weight of planets in kilos, it may be too small in some cases. I don't know how much the sun weighs, but maybe this isn't the most appropriate data type for that. In that case, you should use a much larger number and utilize big int. And well, here, I'm not going to try and pronounce this number, but it is much higher. Now, if you have to save numbers with a comma, the ideal would be to use double. There is one more data type called float, which is for smaller numbers with a comma, but with double you pretty much cover the bigger numbers, isn't it right? If you are making economic transactions, it would be ideal not to have any type of error when saving the amount of money that a client has, for example. Because if at any time there is a mistake with this info, we just don't want any mistakes there. So for numbers with commas, ideally your best bet is to use double. Now, for date, we have the data type date, which strictly accounts for date, year, month, day, and nothing else. But if we wanted to account for the time, hour, minute, seconds, we should be utilizing the data type datetime, which does just that, saves the date plus the time. And there is also another data type, which is called timestamp, which also works like datetime. It allows you to save the year, month, and day on top of the time, hour, minutes, and seconds, right? But different to datetime, timestamp will only work up until the year 2038. And I'm surprised that there are many programmers who aren't aware of this. They're all designing their databases with timestamp. And in the year 2038, we will most likely have a database crash. But hey, surely they will start to come up with features and code to patch the issue, as it happened with the crisis of the year 2000. And there's an interesting fact. So now you know, for date and time, try and stick to datetime. To put together the design of the database and all the tables, you can do it however you want. You can do it with Notepad, with Microsoft Paint, with paper and pencil if you want. I recently started using this tool, which is actually quite interesting. It's called SQLDBM.com, and it allows you to put together this database layout. So when we enter a new project, we just do the following. We right-click and select Add Table. So going back to the example of the academy, first we're going to have an academy on the one hand. So let's create the table we're going to call Academies. Here we can already see PK column name, right? PK refers to primary key. So here we are going to save the ID or identifier. So I type in ID. If I click here, it gives me the data type. I'll select integer. There we have it. So now we have our primary key. Now down here it allows me to put a column. Our academy, what will it have? Well, it has to have a name. So I put in name. Now the data type, let's type in varchar with a length of, say, 100 characters. So as to not falling short. What else can our academy have? Can have a phone number. This info, instead of saving it as a number, since it may have a plus sign, a numeral, it can vary a lot from place to place. It may use a parenthesis. And also, even if it is a set number, if you're not going to do any operation with it, your best bet is to save it as text, since it's not really the case you're going to add up phone numbers. So I'm going to set it to varchar, and I will assign 45, I think it's fine. The academy could have a website, so I will name a new one web varchar, and we'll set that to 100 characters. Okay, for now, we'll leave it there. Very simple. There, we created our table of academies. Good. And now we have to create the teachers table. Okay. So, I put in teachers. Let me move it over a bit. Here. Perfect. We click edit, and there it is. Just like academies, this one will also have an identifier. I'm going to name it ID, data type, integer. First column, a teacher will have a name for sure. We set this one to varchar too. See, varchar is one of the most used data types there are. A name, I'm not sure how much. I'll set it to 80. In case they have a second, third, or fourth name, you never know. And surname, also varchar 80. Now, the teacher could also have an email address. The maximum length an email address may have is 255 characters. I remember reading this at some point, but you're welcome to look it up. I think that was it. They can also have a phone number. And the length I'm going to set for phone number, I'll keep it at 45 to be consistent with the phone number data that we set for academy. Fine. Other important information to account for is what specific academy the teacher belongs to. If we don't, we'll have a record of teachers and we wouldn't know which academy each teacher works for. We add another column called academy_ID. The data type will be integer since it is an ID. This way. Integer, let's remember, accounts for numbers, right? And now to associate this academy with this ID here, we're going to do the following. We edit academy, and we make ID have a relationship with academy ID. There, it created a new one for me. Then I will edit it. This last one I will delete, and I will add it here. It's better there. Let's see. That's better. And this way, it's setting a correlation to this table. So, teachers will have an academy, perfect, and here it displays FK, which means foreign key. Good, we have teachers. Let's add the students table. We put in students. A student is quite similar. The type integer. We will have the name. Data type varchar. Surname. The name in varchar has to have 80 to be consistent with the teacher's table, since we use these two types of data in that table. Email address, set that to 255. What else? Phone number, they may have a phone number to contact them. And there we have it. Good, there we have our table of students. Now, this student will also belong to an academy, so as to differentiate them. So here, we edit academies again. We set a relationship, this time with the student's table, and there, we created the ID. We're going to change the name, and I'm going to put in academy_ID. Typically, in database design, well, we can't use spaces. But instead of using camel case as it is in programming, which is capitalizing each word, if you write, for example, hello, how are you? This is camel case. In databases, we often use the underscore, which is much easier to read. Okay, so there we have our table of students. Now we have courses. We create another table, names courses. It will too have an ID. We select integer. Okay. We have a name for the course. In name, I am going to set 100 characters. And maybe we could have a description of the course in which every topic of study and everything to be learned is well detailed. And this description, being a long line of text, I'm going to set to text so that it may fit. And there we have it. Perfect. Now, this course is going to be taught by a teacher. So a teacher is going to be associated with a course. We click Add Relationship, then we click here. And there it created this column, which is going to be the teacher's ID. So we edit again. And let's see, because it's straying a bit far away for comfort. And there it is. We edit one more time. And in this field, we are going to put in teacher_ID. And there we have it. Perfect. As we are designing a database, it's very important to ask ourselves this question. Does one table reference many elements from another? For instance, can one student have many academies? Well, not in our design, no. One student can only have one academy. But if we were to ask, can one academy have many students? In this case, yes. So the students table will have academy ID, only this one, because there is only one academy. But students, there are many. The same happens with almost everything. Teachers. Can one teacher have many academies? No, they will only have one academy and will belong to only one. But one academy can have many teachers. Therefore, teacher 2 has an academy ID. There would be only one academy, but many teachers. Now with the courses, what happens with the courses? Can a teacher head many courses? Well, I think so. They may teach many courses. But would a course be taught by a single teacher or several teachers? Well, in that case, a course can only be taught by one single teacher. So that's why we are assigning teacher ID here. And then there is only one teacher for each course. We have many courses, but one teacher for each one of them. Now, let's consider the following case. How do we assign a student to a course? The following happens here. Can a student have several courses? Yes, most likely a student will be taking several courses. And can a course have several students? Sure. What we have here is more commonly known as many-to-many, which is when a table includes many elements from another. In order to solve the situation, we'll create an intermediate table. So we create one more table right here, and this one will name students underscore, let me see, by courses. This way, we may name it any way we like, as long as it's understood that we'll be saving students and courses here. And this will have an ID to identify each transaction, data type also integer. And before we move on, we'll set the correlation it should have. So, first ID will have a relationship with this table. There it is, students. Now I will change the name here. This one will be student ID, this way. Okay, so in this table, we're saving the student. And in courses, as well, we set the relationship this way. And we assign it here. There it created the new column. I'll be naming this one Course ID. Perfect. So in this table, we'll be able to save all information regarding what course each of the students is taking. And there we go. This database is already taking a more complex outline. Now we only need to assign space for notes. In the initial design, I believe I named this subjects instead of courses, but it comes across as more or less the same thing. Okay, now we create another table, and we'll name this one Notes. This will always have an ID as well. We may not need it if we identified the students and the course as primary keys. But to be honest, that might end up being confusing. I really always advise to try and create an ID that's independent from the table. So, for each table, we create an ID like this. And this will have, this will have a note. The note, as we said, can have a value with a comma, yes. So we are going to set double as data type. And that's it. Although double, it's for a very large number with a comma. Here we're talking about a 1 to 10 range, or at most, if the note ranges from 1 to 100, 100. But for smaller numbers, we can use float. There we have it. Okay, we already have the grade, now we have to assign a student. Let's go here, add relationship to notes, perfect. We change the name, student ID, and now we are going to add a course. We select add relationship once more, and there we have a course. We edited course ID, and it's done. Well, we now have a somewhat finished version of our first database design. This will most likely change over time, Most likely we'll be adding more tables, more columns, but anyway. Now, this website provides us with a very useful tool. And if we go here, in this part, it allows us to generate the SQL code so we can use these tables. Later, we're going to learn what SQL code is like in depth, but it's a good thing to consider. So if I select, for example, let's see, students, and press play, it generates the SQL code to create the students table automatically. It won't let me select several tables because there's a paywall, but we can do each table one by one. If I do students by courses, there I have the SQL code automatically. And now let's get into detail on what this code does. We already finished the database layout design, but we still do not have an actual database yet. We still don't have anything up and running. To take the first step in this enterprise that is database design, we're gonna work with phpMyAdmin. For that, we have to download a program that you might or might not already use called Xampp, right? You simply click download, then install and follow the steps. Click next, next, next. It's that simple. And that's it. Once you have downloaded it, we're opening it. Look for it in the start menu, Xampp. There it's starting up. Let's see, it opened up in another window. There we have it. Here we have Xampp. Let's load, on the one hand, MySQL. We hit start. There we have it. It says that it loaded MySQL on port 3306. So now we need a program to connect to this port 3306 and thus connecting to the MySQL database. Instead of using a program, Xampp already provides us with a preset. It works with PHP. So we load this one here called Apache. We hit start. We wait a moment. And there, it's loaded on port 80. What happens? If you clicked start and it didn't work for you, most likely you have some other process that is blocking it. This could be Skype, VMwater. What else was there? No, I think those are the main culprits. It's happened to me that I had to shut down those processes for this to work. Just keep trying out stuff and you likely make it happen for you. Okay, we got port 80 up and loaded, the Apache. So now we go to Chrome and we search. Type in localhost / phpMyAdmin, like so, and press enter. If you are using another ID, you may have to type capital M and capital A. However, this should work well enough for you. Perfect. Now we enter this page. What we did was setting up a local server, and that brings us this tool called phpMyAdmin. And this manager allows us to create databases, modify them, build tables, all in a very simple way, and also execute SQL code, which is meant to manage the databases. So, here on the left, we have the databases. Let's create a new one by clicking here. And we are going to name it Academies. Now, as data type, we are going to use UTF-8. Where do we have it? UTF-8 bin. Typically, it's not going to cause any issues. What this UTF-8 references is the type of characters the database is going to save its data with. It varies from Chinese to Arabic to Latin America. It varies a lot, but with UTF-8_bin, you won't have any type of problem, whatever the language is. So with this, we create the database. This could have been done with commands as well, with all SQL code. But as a start, I think it's fine to do it first with a graphical interface. And what do we have to do? Well, let's create the tables. And granted, it has to be done in a special order. Here we have our tables. If we create the notes table first, we'll have to put in the student ID and the course ID. but those columns don't exist yet. That will make it difficult for us to be able to reference them. So we definitely have to start with tables that don't have any kind of foreign key. The first will have to be academies. So we put in table name academies. Let's see how many columns does it have. 1, 2, 3, and the ID 4. 4 columns, perfect. Okay, the first name, ID, data type, integer. If we go over a bit to the right, we're going to have 2 letters here, AI, which means auto increment, which basically makes it so that each new value increases 1 by 1, meaning each time a new record is created, it will be 1, then 2, then 3. And that'll be the ID that will distinguish it from the rest. Okay, so that's auto increment. When we set it to that, it automatically displays that as our primary key, also represented by pk. Next one, name. We put in a name, varchar, and what data type? 100. Okay, perfect. Moving on. Phone number and website. Phone number, website, varchar, 100, varchar, 100. Wasn't it? No, phone number is 45. There we have it. Once we're done compiling this data, now we have to click down below here where it says save. At first glance, it is a bit complicated to see so many buttons and inputs distributed everywhere, but you get used to it after using it for some time. We hit save, and that's it. There, we created the Academies table. Perfect. Now let's create another table. And the next one can be any one that only integrates the Academies ID. That is, it can be teachers or students. Well, let's create teachers. It has 1, 2, 3, 4, 5, 6 columns. Okay, where were we? Here. Let's create one more. Oh look, it created the columns by default. We're missing 2, so I create 2 more. Go, and there we have the 6 columns. Table name, teachers. We also have ID, name, surname, phone number, email address, and we have Academy ID. Okay, ID will be the same as the other one, auto increment. There we only have the primary key. This is a type of indexer in the index. Name varchar, surname varchar, phone number varchar, email address varchar. Name I think we've said on 100 before. Phone number 45. Name was 80. Okay. 80, surname 80, 255. Okay, now what about Academy ID? For this column, let's do the following. First, we create the table. We click on save in this way. There we have it. Perfect. There we have teachers. And if we go here on teachers, we're gonna have the structure field up here. We click on it. Okay, there we have the table structure again. We look at each column, the data type, and here we have a part that says relation view. This allows us to do precisely that. So we click here, and here it lets us make a relation to another table, like so. This relationship we're making here, we gotta name it something. We can name it Academy_FK as a foreign key. Okay, here we have to select the column that's being used. We put in Academy ID. Then it sets a reference to the table, to the Academy's database, to the Academy's table, and it sets the ID column by default. And this onDelete, onUpdate thing means the following. What happens if we try to delete a row from the teachers table? That is, we try to, for example, we try to delete an academy, but that academy has teachers. What action will it take? Well, here we can choose what we want it to do. If we set it to restrict, it means that if it comes to removing an academy and it has teachers, it will prevent this from being done. It will not work. If we set it to cascade, what it's going to do is delete all the teachers it has. That is, if we delete a row, right, that belongs to a certain specific academy, it will automatically remove all the teachers that contain it. In this case, it is common practice to do something called soft delete. And basically what this does is put one more piece of data, for example a column, to be called quote-unquote is active or not, that is a Boolean value. If it's active, it means it's okay, and if it's not active, it means that it is deleted. So, truly, when someone tries to delete a row or something like that, it is never being deleted. It is simply changing this value to active or inactive. And that's why, when you think you're deleting all the posts you made from Facebook, they're not really being erased. They're stored in a database somewhere. They just stop showing them to you. But well, if you want it, we can go over it later in more detail. For now, we'll leave it like this in restrict. And we hit save. Perfect. There we already have our data, our table teachers created, and now we have to continue with the students table. So let's create another table called students. We repeat the process, it's more of the same. Name, surname, what else? Email address. We add another row. Phone number. The ID has to be set to auto increment as well. There we have it. Name varchar, surname varchar, email address 2, phone number 2, 55, 80, 80 to maintain consistency, and phone number 45. Did I miss any data? Let's see. Well, Academy ID, this one also has to have it. So we add it. Academy ID. We set its type to integer, perfect. And we save it. There we have our students table. And students will be related to academies. So I'm going to assign an Academy FK on it too. I'm going to put Academy underscore student to be able to differentiate it. What column? Academy ID will make reference to the Academies database, to the table Academies, and to ID. Perfect. We save it. Done. Moving on. We already have the table teachers, so we can make the table courses. And courses has only one teacher. Here it is not necessary to assign an academy to the courses table, since we can tell which academy a course belongs to because of the connections it's making. If a course has a teacher and a teacher belongs to an academy, we already know which academy it belongs to. Okay, let's create that table. We name it courses, ID, name. What else did it have? Description and teacher. Teacher underscore ID. Always try to avoid using accent marks on column names because, well, it can cause problems. Go over to the right, auto increment. Description had data type text since it will save long lines of text. Name, we keep varchar of 100 characters and we leave teacher there. We hit save. Let's go to courses, hit structure, relationship, and we create a constraint. Instead of student, it'll be course. Here we put in, oh, teacher ID. Right, this would be teacher course. There we have it. Table, teachers, and ID. We save. Perfect. What are we missing? Now we have to assign students and courses. We have to create this intermediate table. Okay, let's create another table. That's called just as is in the name, students by courses, students underscore by courses. We'll have an ID, a student ID, and a course ID, this way. The first one we will set to auto increment, and the rest stays as is. We hit save. Perfect. We assign the relationship. In name, we are going to put in, oh, I got the name wrong. I typed students with an X. Well, let's edit the name real quick. Let's see, where do you do this? Well, I don't see the option here, so I think it's going to be easier to execute SQL code, which is super simple. If we go over here to the SQL part, here we can write code to do everything we did, but directly from the console. We'll type the following. Put in rename, the name of the table students. Here's the extra X. That's how it is now. I copy this, and I'm going to type 2, and I remove the X, this way. Good. This, I believe it should work. Oh, I missed a word. It's rename table. Rename table from this name to this one. These quotes don't need to be there, but it's okay. I'll leave them there. And I hit go down here all the way to the right. I click here, and the name is fixed. Perfect. Here, it's not visible because it's not updated. If I click on Academies, there, it is updated. That is, if we hit refresh, we'd get a more accurate look. There it is. Perfect. Okay, I think we left off in the relationship setup. We type in student, student courses, FK, and this will reference the student ID to the student's table. There we have it. We add another one. This will be the other way around, course student. We put in course ID, database academies. If I move it over here, it looks better. Perfect. Table, courses, and there's the ID. Okay, there we have it. And we save. Perfect. What happens if we don't set these relationships up? Well, our database would work anyway. We would be able to save data, and we could make queries so that it brings up the necessary information. However, by setting up these relationships, you specify precisely how one table is related to another table. When it comes to making queries, it will run much faster, especially with large databases when they rack up to hundreds of thousands of records. What are we missing? Notes. We set up notes and we're done. Let's add another table. We name it notes, ID. We established the value for notes was going to be float. Here it is. Course ID and student ID, this way. And we set auto increment to the ID. Perfect. We save it. Okay, now notes. We'll also add the relationships to those. We put in whatever nomenclature you choose here. Make it your own. Whatever makes it easier for you. I'll name it note student. It will refer to the column student ID, to the table students, and to ID. We add another one for the course. So we put in note course. _FK to indicate that it is a foreign key. We indicate course ID. Well, in this part on the right, I choose courses. It's fine right there. Perfect. We hit save. And it's done. Now we have all of our database layout designed. phpMyAdmin also allows us to add data, modify it, and delete it. If we go, for example, to academies, it will not be showing us any data because we have nothing loaded. We can go to insert, and here we can add information to a new row to this table. We can type in as the name of the academy, I don't know, Online Academy of Argentina, for example. On phone number, we put in the phone number. Website address, Online Academy of Argentina.com. After that, well, all of this is just to add another piece of data, but it isn't necessary. ID, as we said, we leave it empty because it fills up automatically. We hit go, and voila, there, it has automatically created this SQL code that inserts a new row in that table. Now, if we go to academies, we can see that there is already an academy created in our database. We could easily edit it, delete it, or well, do whatever we want with it. Also, if we so wanted, we could export this database as easily too. We click here on export. It's gonna take a moment. There we have it. And we choose the format we want it to be exported to. It could be CSV, could be JSON, it can generate a PDF, but the most usual of all is SQL. Okay, we set it to generate the whole thing. We hit go, down here all the way to the right. And just like that, it generated this SQL file that is our entire database. I can open it here in Visual Studio Code. Let's look at it for a moment. Okay, here I have it. This is more or less the code it generated. We can see that it creates the Academies table. It also does an insert into the Academies table, which is this value we set up. But, well, there is no other table. There is only the Academies table. That's mostly because I didn't select to export everything in here. Of course, being positioned in the Academies table, it only exported that one. If we wanted it to export the entire database, we'd have to go to the Academies table, and there we click on export. And now it's a different story. We hit go to see what this is generating. There we have it. Now we have our entire SQL code to design this database. And we could calmly go, I don't know, to the production version, to the online version we might have, and we import this database layout elsewhere, simply by clicking the import button. So this is really quite useful. Many times I used it when I designed some web page locally and had to upload it to the server. I just exported it from here and imported it from the other end. Well folks, we'll leave it here for now. In later videos, we are going to learn much more about SQL language and how to create database queries. See you in the next video. Goodbye for now. In this section, we're going to learn how to use SQL. It is the language that allows us to make queries to the database, create tables, modify data, everything. It's an acronym that stands for Structured Query Language. An interesting fact about SQL is that it was invented in 1970, so it's been approximately 50 years since it was created, and if you watch this video much later in time, it might be even longer. And proof of how solid and rigid this language is the fact that it's still being used, no matter how many years it's been. It was invented by IBM in 1970 when they made a database called System R. And in order to be able to consult that database and extract information, they made this language called SQL. But it was only in 1979 that the Oracle company saw the potential in SQL and decided to invent their own database and also their own modified SQL. They marketed it and took it to, well, its full potential. What I want you to understand is that SQL is a language, not a database. We can have different types of database, such as the one from Microsoft, which is SQL Server. There's Oracle's, there's SQLite, which is made for cell phones, and MySqL. And what happens? These are types of databases, and the SQL language is used to query these databases. Now, granted, the SQL language varies a bit between each one of these databases. Say, Oracle's SQL is not the same as MySQL's. They do maintain very similar general aspects, but it varies a bit. If you just started learning, you hardly notice a difference, but when you're getting to a very advanced level, there are quite a few differences. Anyway, if you have to adapt, for example, from MySQL's SQL to Oracle's, it's easy. It's not that it's too complicated. If you already have the concepts well studied, you can adapt without any problem. Now, let's go to the types of queries that we can do with SQL. First, we are going to divide it into two categories. On the one hand, the queries that take care of the structure of the database, and on the other hand, the type of queries meant to modify information or extract information from the database. Okay, to define the structure of the database, we have the following queries. On the one hand, create database, which basically serves to create a database. We'll take a good look later on with quite practical examples, but now we'll go over it in rather broad strokes. Then we have drop database, which is basically used to delete a database. And then we have create table, used to create a table where we are going to save all of our records. Then we can use alter table to modify that table. If we wanted to add new columns or remove columns. And finally, we have drop table, which is used to delete a table. Next, if we'd like to consult or modify information, we will use the following commands. First, select. Select is the most important command of all. We can use it to make searches, to select data, to count the amount of registered users, making queries by grouping users, everything related to extracting information from the databases, whether it is to display a list, compiling statistics, or putting together a report. We do all that with select. Then we have, on the other hand, insert, which is used to add items to the database. Then we have the update command, which is used to modify data. And finally, the delete command, which is used to delete data. With these queries, we cover most of the utilities of a database using SQL. There are more types of queries, but for the time being, we won't be needing them. Okay, let's look at these queries more in depth. First, let's get into creating the database. To create the database is super simple. We simply have to type in create database and the name of our database. We use semicolon at the end. The name, it's important that it doesn't have spaces. In the usual way to put in information for everything database related is using an underscore. That is, instead of using a space, use an underscore always. Then, to delete the database, we type in drop database, the name of the database, and a semicolon. This specification, if exists, is optional. It is not mandatory. But if we use it, it will work for both if the database exists or if it doesn't. Since if we try to delete a database that does not exist by typing drop database, say veterinary system, and that database does not exist, an error message will appear. On the other hand, by adding this, we prevent this message from being displayed, and it takes the action only if it exists. Well, let's consider the next example. Let's say we want to design this table. On the one hand, we have the ID, which will be the number that identifies each of these rows. Here we have number 1, number 2, and it's going to increase like this constantly. Then we have name, surname, and well, date of birth. This table, I don't know, it could be a user's table, an employee's table, just as an example. Now, the funny thing is that the date in SQL is written as follows. Put the year first, then a hyphen, then the month, the day, and the time right after. Okay. If we wanted to make this table, the command would be the following. We start by typing create table, the name that our table is going to have. In this case, I put users. We open parentheses, and well, here's where all the code related to the columns would be. But what I want you to see is that here, the parenthesis is closed, and a semicolon right after it. Always, for each SQL command we execute, we add a semicolon at the end. This indicates that this command ends there. Well, now, each column's information we are going to put in one at a time, and we are separating it by commas. For starters, let's set it to have an ID. Okay? Then we indicate the type that column is going to be. In this case, it will be integer type, which would be a number. And in parentheses, you put an 11, since that would be the maximum size of the number. Then, we can add this term in red. It's completely optional. Not null means that this value can never be null. To be honest, I've been programming for like, say, 10 years now, and I still don't remember it. Whenever I end up Googling it or something like that, but it's good to know. Understand the logistics of how it works. And if we want to erase a table, type in drop table and the name of the table, users, and it's also optional. I have to write it, I end up Googling it or something like that, but it's no. Understand the logistics of how it works. Then if we erase a table, which drop table and the name of the table, and we also end with a semicolon. To be honest, I've been programming for like... Next. Here we create a new column, which is called name. The data type is varchar with a size of 80. Varchar, well, as we already said, it's for text, isn't it? With a maximum number of characters of 80. I set it to be not null, but it could be set to null. This is however you want it to be. Surname also, the character size. Note that it's always separated with a comma. If you don't put this comma, it will display an error. And the last piece of data, date of birth. The data type that I set for it is datetime. I am not using timestamp since timestamp has a limit, which is in the year 2038. That is, timestamp will not work correctly by that year, although most likely all databases will be patched in some way, solved, and available to use. But that's why I recommend using datetime. And this also saves date and time. In this case, I'll leave it as null because, well, I can allow this value to be null. And finally, at the end of the create table query, there will start to be more indications about the columns. In this case, the only indication I'm giving it is this, which is primary key. And in parentheses, I'll put the ID. With this, I indicate that the ID is going to be the primary key and be the way in which the table will identify that that column is the one that differentiates each row. This command is very important that you know it perfectly by heart. Nah, just kidding. To be honest, I've been programming for like, say, 10 years now, and I still don't remember it sometimes. Whenever I have to write it, I end up Googling it or something like that, but it's good to know. Understand the logistics of how it works. Then, if we want to erase a table, we just type in drop table and the name of the table, users, and we also end with a semicolon. This, if exists, is also optional. It means that if the table exists, it will delete it, and if it does not exist, it does nothing. If that table did not exist, and we try to do a drop table with a table that's not there, it will return an error message. So if we put this, we avoid any type of bugs or issues. Okay, and what happens if we already have our table created? We already have it full of data, everything, and we want to modify some value in that table. That is, we want to add more columns. We're not going to delete the table with all the data and create the table again with those added columns. For that, we have the commands that allow us to modify tables. If we wanted to add new columns, we have to put in alter table, the name of the table, in this case users, add column, and the column we want to add. For example, if we wanted to add a phone number, and then we indicate the types of data peculiar to that column the same way we did previously. We set it to varchar, the size that this text will have. This one will be 45 characters. And then come the optional values. In this case, I'll put in null. That means that this value could be null, and that's alright. And we close the query with a semicolon. Now, if we wanted to delete a column, what we have to do is type in alter table, the name of the table, then we put in drop, and the name of the column. And lastly, well, a semicolon. So if we run these two commands, we will be adding the column phone number and then delete it, so we wouldn't have done anything. And what do we do if we wanted to modify an existing column? Well, the command is quite similar to add column. We just have to put in alter table, the name of the table, and then alter column to modify the column. I mean, alter refers to modifying, right? We choose the name of the column and the properties that it is now going to have. In this case, I'm diminishing it. It was 45 before, and now we modified it to 35. What if a text that was set to 45 was now set to 35 and already had data worth those 45? Well, what it's going to do with all that old data, for example, let's say in this case that we had phone numbers that reached up to 45 characters, and now we modify that column, setting it to a size of 35, what it's gonna do is simply cropping them, so you have to be careful with this alter table thing and make it very safe, according to what you want to do, and be sure you won't lose any data, which is the last thing we want to do. And now we are going to put into practice the commands that we learned to use so far. Granted, we are going to need an IDE to be able to work. In the previous video, we learned how to use phpMyAdmin. If you want, you can easily use that IDE. If you don't, there is also this web page that is quite good. The link is sqlfiddle.com. Here it is if you want to check it out. And it's good because you get in and it's used precisely for this, to practice. You can choose the type of database you want, MySQL, Oracle, whichever one you wish. And you can directly input the queries in here. By clicking right here, you can generate the tables. Here I will generate a table for you to see. And on the right side of it, you can execute the SQL code. The truth is that it's pretty good. If you click here in the browser, you can also see the table and all the data you have created. Now, the tool per excellence to use MySQL is Workbench. Let's see how it is installed. If you want to use some of these IDEs that I just mentioned, use that one and skip this part. But professionally, the one that is used the most is the IDE of Workbench. So let's go to Google, type in Workbench, download. Okay, here we have it. Okay, choose your operating system and hit download. Well, here it will ask us to log in, so go ahead and log in or register. Okay, there it allows me to download it after having logged in. And there we have it, MySQL Workbench. Well, installing it is very simple. It's like with almost any other program. You have to hit next all of the time. And it's installed. We choose complete. We click install and there, it's done. I am not going to continue because, well, I already installed it. Well, once in Workbench, what we are going to do is the following. Here we will have an icon, a plus sign, which creates a new MySQL connection. We click here, and what we will do is connect to the MySQL server that we want, whether you're working online or locally. If you're working locally, you can use Xampp, which we went over in a previous video. Here we have it. This Xampp control panel application, it's very easy to use. We click on Start to MySQL, and that's it, it's up there and loaded. Here it is indicating the port that it's using. In this case, it's 3306. I'm not sure if you can tell, but okay. So we will put in port 3306. That's already the default because it's the default for databases. This host name that you'd be using is the IP address where our server is located. In this case, 127.0.0.1, that's the local host by default. That means it would be like the local connection within our machine. If our server, well, is somewhere else in, say, Europe and the United States or whatever, we're going to have a different IP number, and then we'd have to write that IP number to be able to connect. The username by default that we'll use with Xampp, the name is root. And the password, there's no password. It comes empty, it's that simple. With that, we can then connect. Here, when it says default scheme, it's actually referencing the database you are going to connect to. Since we don't yet have a database created for this example, we won't put in anything yet. If we hit test connection, we check that everything is okay. Here it tells us that there is a discrepancy between the version of MySQL that we are using in Xampp and the one that Workbench is using. Truth is, it doesn't matter. We hit continue anyways, and there it says it works fine. Okay. We launch. Oh, I didn't give it a name. We're going to name it localhost. There we have root, IP, all is perfect. Okay. And there we have it. Now, when we double click here, it will connect to this database. Sorry, to this MySQL connection, and that is how you do it. On the left, it's going to display all the databases that we have. In my case, I already have some created. You probably might have one by default, like phpMyAdmin. And what we are going to do now is create a new database. The first command we went over was create database. And we put in the example name, users. Sorry, the name I'll use will be course, for instance. Now we select the entire thing and we hit execute. Let's see. I'll make this bigger so you can better see the line of command. There we have it. Perfect. This button then, what it does is executing the line of command. And this one executes whatever is selected. If this is selected, it will only execute that. Now, to see the database, we click here on this button that says update. There it is. And the new database should appear on the left side. In this case, here we have course. Okay, now let's create a table in this course, in this database. We type in create table, the name of the table, users. We open a parenthesis, and we close the parenthesis, and finish with a semicolon. And then here, we're going to put the names of the columns. The first one, I'll put in ID, which will be, well, the identifier. We set it to data type integer with a size of 11. It will be not null, since it cannot be empty. It will be auto increment, so that it increases a unit at a time. We name it data type varchar, so it's comprised of text. And this value is definitely going to be required. So we put in not null. We add a surname, varchar 80, and date of birth, date, birth with an underscore, this way, and this is date time. This I'll add null to, because it isn't a necessary value. We need to add the primary key. We put in primary key. We put ID in parentheses. Let's see. Okay, I'm missing a comma here. There we have it. We now hit execute. There it is. And in order to check if it was executed correctly, we pull this down here upward. And there, in the last one. Okay, I'm getting an error that says that this database is not selected. If we create the tables just like that, there are two things we have to do. One is to establish the name of the database at the start of the table. We could put in course dot, and so it knows to create this table in that database. And the other, which is also very common to use, is before doing anything, I'll cut this command that we made. I'll type in use and the name of the database that we're going to use, in this case, course. Now I'll hit execute with all of this, and from now on, all the commands that we're going to execute are going to be used with the course database. So I delete this, I paste this command back, and there we create the user's table. See? It runs just fine this time. We don't see it here, so we hit here and refresh. And now we can expand this panel that says tables. And there we have the user's table. If we expand it, we will see all the columns. There they are. To delete this table, well, it's very simple. We type in drop table, users, and we hit execute. It deleted it correctly, and if we hit execute once again, there's an error because it no longer exists. And if we do not want to get this error message, we type in if exists. There we have it. Now it will execute the command well without any error, whether it exists or not. Well, let's create the table again. There we have it. And now what we're going to do is add one more column to this table. We're going to add a phone number. We type in alter table, users. We put in add column, phone number. This will use a varchar data type with a 45 character space. Set it to null. This way. I mean, if you don't put this information, it's not mandatory. If we wanted to make it mandatory, we set it to not null. So we execute it. It ran quite well. If we want to see the changes, we refresh. And there it is. We added the phone number column. Perfect. If we wanted to modify this column, we simply change the add for modify. That's simple. And where it says varchar 45, we are going to make it 30 characters long now. And remember that if we had data, it will cut short all existing data exceeding the 30 characters. We hit execute. There, it ran quite smoothly. We refresh. And now if we see the phone number down here on the left, I don't know if you can tell, it says phone number varchar 30, so it worked fine. The next step is to be able to add data to that table, also to be able to query and modify them. The truth is that it's quite simple. To add data, we have to use the insert sentence. And it's written as follows. We put in insert into and type in the name of the table, in this case users. We open a parentheses, and then here in this part we close a parentheses. And inside these parentheses, we're going to put the name of all of our columns. Remember that it doesn't matter if it's divided into line breaks. Here I put it in 3 lines, but it could easily be in one single line. it doesn't affect if you hit enter or not. The columns that we are going to add will be the ones we are inserting values into. In this case, I've put name, surname, date of birth, and phone number. But it could easily do without a phone number. Now, I'm not indicating the ID because the ID will be added automatically, since we had set it to be auto increment. Okay, then close the parentheses. The sentence values is used, like this. We open a parentheses, and well, here at the end we close these parentheses. And in each part we are setting the value that each column will have. So, for name, I'm going to put the value Lucas. For surname, Moy, and here for date of birth, this date of birth. It is important that it's written this way since we're using the proper language of the SQL format. First we type the year, then month, then the day, then hour, minutes, seconds. Okay, and finally phone number. Also notice that I am using an apostrophe between each word. If the data piece had been a number, you could have put in the number directly. And you could also have put the number in quotes every time. So to never make a mistake, simply always use apostrophes and that's it. You can never go wrong that way. Alright, this way we add a new row to the table. In a moment we're going to try it, but first we are diving a bit deeper into how the other commands work. If we wanted to remove a row, we just have to write this. We type in delete, and we have to indicate which table we want to interact with. So we type in from, and the name of the table, users. So with this we are saying, well, we are going to apply a deleting process to the users table. And here you have to be extremely careful not to execute a delete from users without having finished the sentence. If you type in delete from users, you've now deleted all users from the database. Just like that. And it is a very typical mistake that, well, happened to all of us at some point. But do not let it happen to you in an important project or job, okay? Next, we have to indicate the where here, right? This where will be going to indicate the condition that has to be fulfilled so that this action is effective. So here, I indicate that the ID must be equal to 1. If the ID is equal to 1, it will delete the user. So this way it will only be applied to the user that has that ID. It could have used anything. It could have stated the name to be equal to Lucas. Then it will delete only the users whose name is Lucas. Granted, if there's more than one user with that name, it would delete it too. Let's continue. Now, if we wanted to modify a piece of data, what we have to do is use the following sentence. What I don't like about SQL is that it doesn't have a pattern between insert and update. It would have been neat if they had decided to do it in a way that it is the same for both. It's kind of hard to remember as is, the order and the way to write each query. But hey, always remember that you can Google it or look it up elsewhere at any time, whenever you have to use it. So to make a modification to a row, you have to do the following. We have to type in update. We indicate the name of the table, in this case users, and then we type in the sentence set. And in this case, unlike insert, where we first choose the columns, and right after that we set the values, here we'll choose the column and the value, there, side by side. So we put in name equal to, and also always in between apostrophes, the name we want to use from this point on. We type Pepe. If we want to add another value, we must use a comma. So we use a comma then. Surname equal to a different surname, say Angelini, and the same that happens with delete happens. If you execute this sentence without a where, what will happen to you is it will modify the entire database, replacing it with this data and all the rows you already have. So a where is also indicated here, and we put in ID equal to 1. This way, it will only modify the row that has the ID 1. To be able to extract the data from a database, do the following. Use the sentence select, which is the most used sentence in all of SQL. It works like this. We type in select, then we put an asterisk, This asterisk is a wildcard of sorts. What it's doing is indicating that everything gets selected. Then we won't make any distinction between only selecting a name or only selecting a surname. With the asterisk, we bring up all the data from that particular table. Then we type in from to indicate which table we are going to refer to, and the name of the table, in this case, users. And always remember to end with a semicolon. So, this way what we accomplish is bringing up all the users from that database. Now, if we wanted to search for a specific user, we'll write as follows. We type in select, asterisk, to fetch all the data from that user, from the users table, and here we specify where, in the same way we did with delete and update. That is, the sentence in this part is the same. From where, it will always be the same. Then I indicate the ID is equal to 1, and it will bring up only the users that have the ID 1. And since the ID is something that is set automatically and will auto-increment, it will bring up a user or it might bring none, in case it's been deleted. Next, if we wanted to bring up only the name and surname of a user, we type in select, and instead of the asterisk, we write name. We use a comma since we'll put in more elements, surname, and there we bring the name and surname of the user with ID 1. We'll practice with it and it'll be much clearer since perhaps going over it like this doesn't give you the full scope of how it works. Okay, let's start first by adding a row. Here I am going to copy it directly from the slide. This way we don't waste so much time. And here we have it. We make an insert into the users table. We open a parentheses, we close it. We put in all the columns, minus the ID. Then we type in values, and we set the value for each one in this way. And here we have the year written in this order. Perfect. Let's execute it and see what happens if I run it a couple of times. Well, there I added a few rows. I added 3 rows, or 4, I'm not exactly sure. They're already added to the database. Now, how do we see those rows, right? To be able to see what's in the database, we'll make a select sentence. We type in select, asterisk, from, users. We execute it. And here it shows us all the results. Okay, we have 3 users created. And the ID was incremented automatically. We have ID 1, 2, 3, and the data of each one. Perfect. If we wanted to see only the IDs instead of asterisk, we can type ID, and it will only show us the ID. If we type in ID, comma, name, comma, surname, there it will show us the ID, the name, and the surname this way. Okay, now we're going to delete a row. We type delete from users where ID equal to 1 this way. It was executed. And if we want to see the data again, we make a select sentence one more time. And there we have it. The first row is no longer there. And now, to modify, we type update, users, and we indicate the columns. I'm deleting this right here. Set, name, oops, I made a typo. There it is, equals to, well, another value. I'll type Pepe, comma, surname equals to Angelini. I always close with an apostrophe. Where? Let's remember always to use the where when we make an update. Let's not make that mistake. ID equals to. In this case, I'm going to type 2 to modify whichever one has line 2. There it is. And if we execute, Well, we'll see nothing there. We select once again. And there we have it. If you input Control-Enter, it gets executed on the spot. If I would have tried the same thing, just without the select, we'll leave it like that and see what happens. Let's see. Nope, it didn't get executed. Okay, the good thing about these modern systems is this right here. Here I got an error. If we read, it says that by trying to make an update without the where, it says you are trying to make an update without a where. So this system, Workbench, it detects that as an error, so it prevents it from being executed. If you want, you can change it from preferences to let it run anyway. But it's like a failsafe that it does automatically, since this is such a typical mistake that, well, it prevents you from doing it. Granted, if you are executing this query from the programming code, well, there is no one to stop you there. From Workbench, also when we do a select from users with the asterisk value, we can directly modify the data from this table so as to facilitate its use without having to type in commands every time. We can double-click on surname. In the first one, I'm going to put in Moy, my last name, and I hit enter. And now this button apply appears. And it does just that, it applies the changes. It shows me the query that it is about to execute, so this way it is automatically generating that query for me. I hit apply, and that's it. These changes are executed. And now, when it's time to make this query, if I type in select from users and I put in where surname equals to Moy, we execute, it'll bring up these two. And if I wanted to add another filter, I can type in and, like so, and add something else. I'll put it down here, it looks neat this way. Name equals to Lucas. And now it's fulfilling the condition that the surname is Moy and the first name is Lucas. There's another condition other than and that we can use, that's or. What or means is, well, exactly that. If we don't, then if we execute, it'll bring both of them. Since the first one has the surname Moy, and the second one also has the surname Moy. What's different is the first name Lucas. Both sentences are being fulfilled. Now, if we wanted to count the amount of rows there are, we can do the following. We type in count this way. We open a parenthesis and close it right away, leaving an asterisk right in between. And when we execute this sentence, it says 2. However, that's the amount conditioned by this where. In this case, there are only 2. If we had left the and this way, this count would have brought up only 1. Now, this count looks pretty ugly in here. It's kind of hard to understand what it's saying exactly. As to the name of the column, what we can do is adding as in here. We type in apostrophes and the name of the column that we want. I'm going to name it quantity, and we execute once again. And there it is, much cleaner looking. This as can be applied to any column we already have. If we had typed in name as, well, we type quantity, it will only bring up the names if you were to name it quantity, although it doesn't make much sense there. Let's go back for a moment. Let's isolate the asterisk. Okay, there we have it. It is bringing up a single row since we are using an and. Now, if we wanted to make a search, right, in which I input some text and I wanted to bring me the results of that search, what is usually done is the following. Let's go only by name for now. I type in name equals to, instead of equals to, we type in like, we open apostrophes, and if we put in Lucas, Up until this point, this keeps working the same way it would have worked if we used equals to. If I put in, say, for instance, LUC, it brings nothing up. However, if I add a percentage symbol, like this, when I execute this, there it will find it for me. What this is doing is searching the column name for text that starts with Luke. And then with this, it means the text can continue in whichever way. It's a regular expression of sorts. If I would have typed UC only, like this, it wouldn't have brought anything up, because it's indicating that the text should begin with U. If I include the percentage symbol at the beginning, like this, it will look up every line of text that includes a word starting with U and C. Same thing with surnames. Let's see. Let's type surname. Let's put in a letter O. There it brings up these two because they have an O in the middle. Something to have in mind, if you had millions of data in this table and the search becomes very heavy, one way to optimize the process is trying to make your system not to use this first percentage symbol. This way, it will be much faster. If the search is always going to have to start with the exact letters, right? If I type in MO like this, there it'll bring up every surname starting with MO. But this will make the database run much faster. I only recommend you to do this if the queries are running very slowly, if each one is taking several seconds to process. Well, I think this is enough to serve as an introduction to the huge world that is SQL. But what I truly want you to stay with is that this where works the same way, both for select, for delete, and for update. If we would have had this update, we could have easily had this where in there, like this. This way, all of the data would have been modified by putting this name and this surname, as long as the sentence is fulfilled. Same thing with the delete. We could have had, like this, delete from users, and the sentence could have also been executed. What we are missing, now that I think about it, is the thing about foreign keys. That is, how do we create a table that points to another table? Well, it's very simple. It's more or less the same thing as what we've learned so far. We will create another table called posts. And then it's a table in which each user will be able to save their posts. I don't know, like notes they write. This table has an ID first, which is the same as the other one we created. Data type int, not null, because it has to exist no matter what. And auto increment so that it increases one at a time. Next up, we're going right here. It has the title. The type is varchar. We're going to modify it to be a little longer, 150. And the text, instead of varchar, will be of type text. Perfect. This text cannot be null. The title can't be null either. But we are going to add the author ID. And this way we're making a reference to the user. We could have also put in user underscore ID so as to have more or less the table name, but doing it this other way works for us as well. What is it going to have? Data type integer, this way, and it won't be null. And that's it. Now, in order to indicate that it refers to another table, what we have to do is the following. First, we point at the primary key to indicate that the ID is the primary key. We put a comma because we're going to continue writing. And here we have to type in foreign key to establish this as such. And in the parentheses, we indicate the column of our table that will be pointing to another, in this case, to author ID. It's going to make references to the user's table and to the ID column. When you write it directly into code, it can be a bit messy, since you might get tangled up thinking whether this table is pointing to that one or that table is pointing to this other one. That's why it's good to write it down first, or making a simple, clear design of how all the tables are laid out and how they're connected to each other, so that later on it's much easier to execute this code. So we hit execute. There we have it. We update right here. And now we do see the tables. Here we have posts and users. Okay, if we wanted to add a post, we put in insert into posts. We add the values. We see the columns that we have created. Okay, we have author, ID, title, we're going to learn a bit more about how to make queries to our database. Until now, we have been making rather simple queries, but well, now we're making some more complex ones. In this first table, from this example, we have, well, our users, in which we save the ID, name, surname, and date of birth. On the other hand, we have our posts table, and other than ID, we also have title and text, an author ID, which is actually making a reference to a user. So this one would be the first row over here. When we query the posts table, it's bringing up this number. But how can we go about making it bring us the name and not just the number in one single query? Well, we could accomplish that the following way. We have this query here. Now, in order to read this query, what I want is for you to pay attention to this point first. In the from part, we're referencing two tables, unlike what we have been doing by referencing just one. So, we put in here posts, we type in a letter P, which in reality is nothing more than an initial to be able to use it going forward with the rest of the query, and make it easier to bring up in fields, and make it easier to bring up the users table. I type in a letter U so as to abbreviate that table and make it easier to bring up in the remaining fields. Now, well, instead of the U and the P, I could have used any other letter, but you see, I chose these ones. Now, in the where part of the query right here, you know, we could have done it this other way. Look, in this query, the first thing I want you to notice is the from part. Up until this point, we have been working by selecting only one table, but in this from, in this query, we're selecting two tables. First, we select posts, and then select users. A comma will be used to separate them. Now, this P and this U are abbreviations I chose so I can use them more simply in the rest of the query. Therefore, P references the posts table, and U does so with users. You can choose whatever letter you like. I went with those. Okay, once we know this, we have to go over the next point. When we go to the select, what we are typing in is a P dot asterisk. So, what's it doing here? First, P, what it does is selecting the posts table since we established that as its abbreviation. With a dot, it's like we're inserting it inside this table. And the asterisk is our wildcard. So what it says in here is select every column in the posts table. Perfect. Now we could use a comma and type in u.name, and that will select the name column. Or we could also use comma u.surname and choose the surname column. But we're gonna take a different path in this case. What's more, what we'll do is we'll try to concatenate the name and the surname in a single column, so that it shows me that data conjoined, unified without having to display two different columns. For that, we're gonna use this function called concat. Then we type concat, we open parentheses and we'll close them immediately after. Inside these parentheses, we're putting everything that we want to concatenate. That is, if we put name and surname, it will show me the name and surname in one line. But what happens? We need a space. That way, it's not going to be Lucas Moy all together, right? Then we type in the name. The next thing I add is a space in between quotes so that it has a separation. We put a comma to add one more data item and the surname right after. If we wanted it, we could keep concatenating, putting a comma and adding up more things. Do as you need to. Now, the next thing is to use the as. This one is to give a name to the column. If we didn't use this as, the name of the column would be concat, then open set parentheses and all of this. It doesn't look great. So with this, I indicate that the name is going to be author. Good. It's a little complex, but I think it comes across well. One more thing is missing. If we run this, it's like it doesn't know that the author ID corresponds to the user ID, right? It's like the query doesn't use that logic. For it to realize that much, the following is done. In the where, we put in that in regard to posts, the author ID has to be the same as the user ID. In this way, we make both tables IDs to be coordinated so that it only shows us what is necessary from those tables. If we go back to Workbench, here we have the query we just wrote. We execute it, and we see the following. First, it shows us everything that the post has. It brings up the ID, the author ID, the title, the text. This is all there is to show for this post. The next thing is merely displaying the author. Here it is concatenating the name and the surname. This is the final outcome. We're shown the author's full name. Now, maybe we could be saying, well, but if I already have this data, I don't care for the author ID. And you'd be correct. In that case, what we would have to do is making a selection of exactly what it is that we want to see. So we type in p.id, p.title, what else? p.text. And if we execute all of this, there we can only see that. First the ID, then the title, then the text. And then, well, this concatenation. But look, so that this last part is a bit clearer. If I would have typed u.name, u.surname, like this, this comma shouldn't be here. We would have seen it like this, see? Apart from each other. And now let's add something else. If I had put in u.id, it would be displaying user ID and post ID. And it looks like this. We would have these two columns with the name ID. Okay, perfect. So with this concat resource, we can see everything in one single column. If we hadn't added the where and instead left it this plainly, we would have ran into the next inconvenience. It's as if it couldn't tell the wheat from the chaff, and it brings up all of the data, so it unnecessarily repeats information. It brings up the post twice, but for one letter and author, and another author for the other. And that's not correct, since this author, this one here, should be ID 2. So there it wouldn't work for us. That's why it's important to put in the where. This way. And now we can link the tables through location. In fact, this where that we're using here to link these tables isn't the most optimal for SQL. The reason why is, if it was the case that these two tables had hundreds of thousands of data items, this query would be a bit slow. More than anything else, when we apply a logic in the where part, that's what it is. It's logic, and what it does is processing it in real time. Therefore, it's making the comparison at the moment of executing the query, and it's pretty slow. That's precisely why we created foreign keys, to link one table to another. The idea of these foreign keys is to use them to know that it already generated that index, and you can associate one table with the other in a properly efficient fashion. If I didn't make those foreign keys in these two tables, that is, if they weren't linked, but one of them had author ID anyways, this query would still work perfectly because it's doing it in a logical way. The idea behind this foreign keys is to enable the use of joins, which we'll get into just now. Joins are queries that use these indexes so that they are fully optimized and quite fast. Let's go over a simple example, the simpler of the joins. Let's suppose we have this query, and instead of using this where, we want to use these indexes to make it much faster. So what we have to modify is the following. We already know that posts will connect to users. So instead of using a comma, I'll type in inner join this way. And by doing this, we're telling it that posts will connect with users. And instead of where, we'll use the word on. And there it is. The rule that it's going to apply to this connection is that author ID is equal to user ID. This way, the query is set to be much more optimized and everything will run faster, even with hundreds of thousands of rows. In reality, there are many more joins, but it's always challenging to recall what is it that each one of them does and which one's best for what outcome. That's why I love this picture, because it sums it all up in a super simple way. This picture is to be taken, printed out, and put up on your bedroom wall as a poster. Because if you're into programming, you'll end up looking it up eventually. Let's take a look at how it works. The join that we just made, to showcase the earlier example, this one here in the middle, if we look closer into this part, it says inner join. How does this work? Well, what it does is that if we query a set A with another one we will call set B, it will take the two things that both have in common. Isn't it right? Which is what we were doing a little while ago. Let's say A is comprised of all posts and B is all the authors. So it will only bring up the rows that exactly match the condition we have set. So that author ID is equal to user ID. This is the simplest of all. So if I look closely, I'll see that what I need is for the data to match. That is, we fall right into this middle strip. In that case, what I need to use is inner join, the example shown here down below. Now what happens? There are, as you can see, all kinds of cases. Let's go to this one on the lower right, which can be the exact opposite. I made it so the author's ID is equal to the user's ID. In this other case, what it will end up selecting is everything but that. That's to say, all of the users and all of the posts that do not match, that's what it's going to bring up. See, here it brings up the A, the outside part, and the B, the exact opposite of what we just did. To be honest now, I can't think of a practical example of the proper time to use this. But it's happened to me that I went, well, this is what I have, but I need the exact opposite of that. Well, I looked at this picture and went, aha, that's what I need. And the only thing that I needed to change was, instead of using inner join, I needed to use the expression full outer join right here. And well, this also provides a well-described example. When it comes to joins, it's very useful to have something like this picture for reference. You will definitely need it at some point. So what I suggest to you is that you try and play a little with each of these options shown here. Try using the right join, the left join, fill your two tables with data, and see what it brings up to you in each case. That way you will better internalize and learn how this works. Evidently, in most cases, I would dare say 90%, you'll be using the inner join, the one that selects exactly the data that you need. But it is important to know that all of this is available. It is very common to use SQL to make statistics in order to know what the highest price is, the lowest price, some sort of average. For all of this, the most usual methods are these following functions. Well, we're already familiar with the count function. We went over that one. What it does is count the number of rows. And just like this function count, we have several more. On the other hand, we have max, and what max does is bringing up the maximum value from whichever column we point to. If, for example, our table has a column called score, and we make a query by typing in the sentence max score, well, it'll bring up the highest score. If we type in min, well, it will be the opposite. It will bring up the lowest score. Let's say in case we put in AVG, just like this is what it will do. It's gonna bring up the average score. That's to say, for instance, we have one score of 10 and another of 4, and that's it. What it will do is bring up a 7, since 10 plus 4 equals 14, divided by 2, which is how many scores we have in total, equals 7, the average. It's not like it will tell us which scores repeated the most. On the other hand, we also have sum, and what sum does is a constant summation. We could have, for example, an instance of a table of bills, and we wanted to see it make the summation of the prices of each and every purchased good. The sentence does just that, bringing up the end result. Let's create an example of this so that it's perfectly clear. I'm making a new table. Okay, I'll be naming this one products. There it is. It will have an ID column, data type integer. Let's make it not null and auto increment. Well, now I felt like typing exclusively in lowercase, but it's all the same really. Okay, now let's create another column called name, the name of the item. It'll be a data type varchar set to 100. And finally, a price column to make it as simple as possible. This price one will be data type double. There. Now we have to add the primary key. That's going to be the ID. And there we have it. I execute this. Perfect. If we refresh this, here we can see the table products was created. Let's add some values to it. We can take a different approach to this so we can go around making the query. I'll make a select sentence from products, like this, and I'll add it directly from here. This, well, strikes me as a simpler way. Now I am going to name the first item. Let's name it sneakers. And price, I'll put in $30. On with the second one, pants. Price, $34. Now let's put in a shirt. We'll leave it at, say, 23. And finally, slippers. We'll put an $8 price tag on that. Let's keep it simple. Here on the lower right, I'll click on apply. And as we can see, it automatically generates every necessary query, right? There it's applying the insert, the database, products, and there it assigns name and price. I hit apply, and it's executed. If I execute the select, it brings up everything. Well, then, we type in count, it'll bring up the total. There we see 4. If we type in max and price, this way, there we can see which is the highest price. See? That would be 34. If we type in min, M-I-N, it brings us the lowest price. And if we put in AVG, there, it's calculating the average price. Okay, if we add up every item and divide it by the total amount of items, we get 23.75. And finally, let's try a sum sentence, which makes the summation of everything. If we add up every price, we get 95. That means if a person would have bought one of each of these items, they probably had to pay $95. Okay, now I think we're ready to learn about subqueries, which, well, tend to get quite complicated because it's a complex topic. So let's do the following. Let's create a query in which we're going to type in select from posts, just like this, and let's search for an author ID. Let's suppose that we want the ID to be that of author number 2. There it is. In this case, well, the user that is registered has ID number 2. So we execute this. It doesn't bring up anything because we do not have any posts with that ID. But if we wanted it to be from ID 2 and also from ID 3, here we won't put in an equals to symbol. Instead, we'll use in, just like this. And in parentheses, we'll assign the values we so wish. For example, it could be 1, 2, and 3. And if the ID of the author is within those values, it'll show up here. So when we execute, there we have it. In this case, the author's ID is 3. The big idea of subqueries is that we don't stick to these hard-coded values, but instead obtaining values in a dynamic way. So I'll erase these now, like this. And here we're going to write the subquery. We put in select. We're searching through the author's ID. We put in ID from author. And well, we bring up everyone. So in this way, it's going to bring up every author as well as the value ID. So that when I make the in sentence, it's going to verify that the author's ID matches with any of these IDs that it brought up here. So when we execute this, let's see what happens. Okay, I fumbled the name of the table here. It's not author, but user. I mixed those up. We execute once again. And now it works. But the idea is that it makes some sense. In this case, it wouldn't make much sense to make a subquery. But if we wanted to obtain the users that start with, say, the letter L, we put in where, name, like, and in between apostrophes, we type in L and a percentage symbol right after it. So this percentage symbol would serve as some sort of wildcard, indicating that results have to start with an L followed by any other letter. If we run this once again, now it's bringing this up. If it would have been P, meaning results have to start with P, it brings us no results. Another way we could have made a subquery, such as this one, can be to use the not in. With not in, we tell the database to bring up all posts from authors that don't have an L in their name, so the exact opposite. In this case, well, we have none, since all posts have been made under the name Lucas. This would be one of the simplest subqueries that exists, but I assure you that this type of process can get immensely complex. Okay, now let's learn how to concatenate two different queries. First, let's make an ordinary select. From users, there it is. Oh, I made a typo. Course users, there we have it. And I'm going to search again for users that start with the letter, let's say L. Back again. There it is. And now let's say I have another query, same as this one, but starting with the letter P. And I want to be able to concatenate these two queries because these are two different queries. This way. To do that, the word we'll use is union. Let's remember that when we put this in, we do not have to put the semicolon in the first query, but in the second one you can put it in. And all of this would be a single query. If we execute this, it will begin by running this query, and then it concatenates it with the second query. If we had put in 3 union, like this, and run it like this, it keeps bringing us 2 rows, because since there's repeated data, it ignores the command. The system does everything to avoid repeating data over and over. This one is truly rather simple. There's not much more to it than that. It simply takes a query and makes it one with another. Finally, let's learn how to use the sentence group by. Let's make a simple query once again. Let's not make it so complicated. And now what we will do is make it so that we're able to group these users. If we put in group by and we choose name, for instance, the final result will reflect a group of the different names that we have. In this case, we have only 2 different names, so the result will remain the same regardless. But if we had chosen surname instead of name, here we have the same surname. Let's put it in like this. We execute and group by surname. As you can see, it will only show us one row, the one in which that surname matches. If we were to have different surnames, it could have displayed different surnames. So the only thing that the group by takes care of is that the chosen surname is not repeated. This is usually very useful actually, maybe not in this example, but it definitely is for a date. If we wanted to group by, say, a month, we simply put in month, just like this. We open a parentheses, and we provide it with the date of birth. Then, this way we're gonna group users according to their date of birth. If we execute that, there it shows us a single value because, well, we have the same date in this case. Look, let's change it. So we put in a different date. In the case of Lucas, I'll make it a different year. 89, May, there it is. We'll apply that. Hit apply, finish. Okay, and now we put the group by back in, and when we run that, well, there it shows us the different dates because it's grouping them only by month. This is very useful if we care to know how many people have a birth date during that month. We can run a count command like this. Also, I want to bring up the date of birth to know which one is the one that it's grouping. And there it is. Here it says that in this date of birth, well, in this case, in that month, there's one. If we wanted to know exactly what month, we can also put in month, like this, here. And it displays that during this month, month number 4, there were this many, and for month 5, May, there was also only one. If we put in an as right here, we can change the name of this column so that it is clear. I put a month, and here in count, as quantity. When we execute that, it looks much neater. And look, we'll put in the same month. This is how it would look. I'll make another ordinary select, course.users. We're going to change it. Both are going to be in May. I'll type May in here. And they're also in different years. Now, when I execute this, I know that in May, month number 5, there were these many. Well, folks, we reached the end of the course. I hope you've enjoyed it and made the most out of it. Leave your thoughts in the comments below. Let me know what you think we could improve. And I'll see you in the next one. Ciao.